Now, how would you get between 130 and 140? Well, it's really just like what I was trying to show you with the previous example. You end up subtracting. So if you want the percentage of males who had a systolic blood pressure less than 140 but greater than 130, you would have to subtract. You would subtract the areas. So the area for the bigger z-score, right? You subtract the area for the smaller one, you subtract it off, as you can see. Where's that area? Right here. And you get this. And so the percentage is this difference, which is about 20.89%. Okay. Okay, let me now show you guys, let me now show everyone what's happening through Desmos with this. I think Desmos, it's a little bit easier to see what's happening because the graph is right next to you. So bear with me, I gotta share Desmos. Oh boy. Bear with me. Okay, so here, okay, for Desmos, right? What we're gonna do now is we're gonna answer the same question now, but we're gonna use z-scores. We're gonna use Desmos though. So in the notes, again, you should have the notes in front of you. I emailed them to everyone. The first z-score was 1.0714. So for the percentage of males less than 140 millimeters, right, we had 1.07, let me see if I can find it, 1.0714, right, 0714. And we can see that we get something, we don't get exactly what we got before because we rounded, but we got 0.858. That's the area to the left of one. That's the same as the percentage of data values less than the z-score, which is the same as the percentage of data values less than 140. So it's about 85 point, we convert this to a percent, 85.8%, approximately. For part B, right, it's the z-score was 0.3571. Now I'm just making the max, the other z-score. So this is less than the z-score. This is part B. The area to the left of this turns out to be this thing. Which is 0.6395 about. So if you convert that to a percentage, you get about 64%, 63.95% about. Now, if you want the area between, okay, let me get rid of this. Take the smaller z-score, which is 0.3571. The bigger one we get is, what was that bigger one? 1.0714. So the percentage of data values between the two, we want the area. You can see from Desmos, we get this. I mean, you could subtract, which is essentially what we did, but here and here also you can get it directly from Desmos. Okay. Are there any questions on this? Okay, let me stop sharing and let me now start reviewing. That's really it for new material. So what I'm going to do now is I'm going to start reviewing from chapter 6. Okay. All right. Okay. Okay, so for here, one of the big things we dealt with in chapter 6 was those annuity formulas. And the idea here, remember, is, I mean, this is not brand new, so it's review. What happens here is that, you know, you have some account, There is compounding interest, but the simple case, so to say, is when you only make one deposit, right? And you're letting the money build interest on its own. But with an annuity, remember, you're going to make many deposits. You're going to make many deposits, not just one, not just two. You're going to make a lot. Well, you could make just two, but you're going to make a lot. In that case, what's going to happen is, not quite there yet, there's going to be a formula that we will use. There was that TVM solver, but I think most people did not like that. It could have been, it could be my fault from the way I explained it, I don't know. But what I want to do now is focus on the formula. Even though I did present it in lecture, let me just focus on that though. So let's say we want to solve this one. I'll show the formula shortly again. Let's say we deposit $100 a month, each month into an account, and the account is earning 6% interest, and it's being compounded monthly. So we're not taking any money out, we're making deposits, many deposits. That's why we have an annuity. And we want to answer these three questions. How much will we have, okay, in the account in 15 years? That's the first thing we want to know. How much will we have in the account in 15 years? Then we'll answer how much total money we put in the account and how much total interest we earn. We'll get to that as well. All right. But this is the formula we're going to use. We've seen this before, and I'm just reminding you what the notation is. A is the balance after T years. PMT, that's how much you're depositing each time in this case. Right? Notice we're making many deposits. That's why we have an annuity. R is the interest rate, annual interest rate, but you have to write it in decimal form. And the other stuff. N is how many times the account is compounded in a year. T is the number of years we plan to make deposits. Okay, that's what T is. And of course, also, this is actually, again, I'm just reminding you what the convention is. If the compounding frequency, for some reason, was not explicitly stated, we're going to assume that the account is compounded as often as we make deposits. I mean, here they tell you it's compounded monthly and we make monthly deposits. But if for some reason this was not listed, how often it's compounded, we would assume it's being compounded monthly because we're making monthly deposits. Okay, so let's move on. So now we're going to use this formula, and I'm putting in the notation here, okay, the variables. So again, A is what we're looking for, right? We want to know how much we're going to have in this account 15 years later. So this is the balance after T years, and that's what we want to calculate. Our regular deposit, right, $100 per month, so PMT is $100. R is the annual interest rate, 6%, but we write it as a decimal, 0.06. Okay? N is the number of compounding periods each year. Now, since it's being compounded monthly, and there are 12 months in a year, that's why N is 12. T is how many years this is going on, which is 15 years. How long we're making deposits for. 15 years. That's our notation. I rewrote it here. Now we're putting it into the formula, right? If you go back to the formula, right, here, we're putting that notation in. So this formula we have to calculate. So I guess conceptually, it's easier to set up, what you have to do here, as opposed to that TVM solver. But now we have something not terribly nasty, but something we have to calculate. But we have calculators, so that'll help us. So we plugged it in. And again, you want to handle the top and bottom separately, and you want to use order of operations. I mean, the denominator is easy. You just divide, you get 0.005. For the top, you want to work with the innermost parentheses first and work your way outward. That's really what you want to do here. Okay? So here, if we have 0.06 over 12, well, that's 0.005, right? So we have 1 plus 0.005, okay? That's on top here, which is 1.005. Then we raise it to the exponent. The exponent is 12 times 15, which is 180. So we're raising this to 180. And of course, that's where a calculator will come into play.